Okay, so the next thing that I was going to do at this point is just to go through and just go with the very simple example problem that, it's the default one that comes up, and just sort of talk through the process, how the process works in OneUp. So I'm going to go share my screen, and I'm just going to go into the test course here, and I'll go just make a new problem in, I don't know, miscellaneous. We'll add it to that's this one here. Problems. Okay, so we're going to do the templated dynamic problems. The raw Lua ones require a little more explanation, and by and large, people aren't really using them just because the templated is a lot easier and just as powerful. There's a very limited set of circumstances where the raw Lua might be better. And I think we're not running into those. We may actually delist it from the list of problem types. Not that we're going to drop support because there's not really anything extra, but we may make it so that it's harder to get to. So just so people don't stumble across that by accident. So of course we have at the beginning all of the standard problem stuff, instructor notes and authors and skills and tags and all of that. And for the moment, I'm just going to ignore that because we're just going to concentrate on the Lua part of it, which is down here. So we'll talk, the add dependency is related to Lua, and we'll talk about that, but I wasn't going to talk about that right off. So, okay, so let me go ahead and increase my font size a little.
Thank you.
Because I don't, it's a little small otherwise. Okay, and so we have the setup code here. So basically we have two parts to the problem. We have setup code, and then down here we have a template. This is for part one. The one thing you do have to do aside from the code is you do have to specify how many points each part is worth. But so the way things go is it's really all of this winds up getting rendered into Lua code in order to get run. And so the setup code is the most straightforward because it's just Lua code. So it's just ordinary code written in Lua. You can write, well, I say literally anything, basically anything there. There are a few of the built-in functions that are not available. And they're ones that we have specifically removed because they do things like write to the file system and other things like that. You're not going to need them in the process of doing ordinary problems. And they're just to make sure that, like we trust instructors, in the system to not be trying to write malicious code, but we don't want to trust students. So we have removed some things that we think instructors could accidentally, could use in a way that students could then, where the instructors could make a mistake that the students could then abuse to hack our system. So it's not that we're worried about you guys hacking the system or you all hacking the system. It's just that we're worried about the possibility that the students could do that. So now in this, one of the first things you see here is that we use this math.random function. Now, the way this is going to work, math.random does not generate real random numbers. It generates pseudo-random numbers, and it generates pseudo-random numbers from a particular seed. And what's going to happen is when a student goes to take a problem, the seed, they will get a different seed, right? We generate one out of, it's something like a quintillion different numbers randomly for each student. So anytime we use this math.random, you're going to get a randomish number. Each student will see a different random number, but it will be consistent for a given seed. So we can use that then to do some debugging and testing, and we'll see that when we get down to that. So this is, but feel free to use math.random wherever you want, call it as many times as you like. There's no problem with using it. Just think of it as giving a random number. The other thing we have the one thing that you can't do is you cannot reseed the random number generator because we're providing the seeding for that. So we did actually lock off that function as well. But you don't need to. You can be assured that it has been appropriately seeded before your code runs. And in Lua, there turns out to be a small bug where math.random, like the very first number it produces is not very random. So we even go ahead and we actually eat the first random number before you guys start running. So you can be assured it's a pretty decent random number. So in this case, what I wanted to, you can put Lua code in both the setup and the template part. But if you have big complicated code, you'll find it easier just from a style perspective to put it in the setup code part. So what the system is going to do underneath is it will turn this into, it will run the setup code before your problem begins. And then when it's time to display things to the student, it will go down to the template and it will display this to the student. Now this is rich text formatted. So if we want this to be, if you want certain things to be in bold or so forth, it's very easy to do. And within this, we have two special sets of syntax that let you escape out to Lua code. And the first is square bracket vertical line is used when you want to put in a value of some sort. So it just means that this Lua code will be run and whatever value it returns will be put in that location. So for instance, in this case, we have set up R1 and R2 as Lua variables in our setup code. This is going to run in the same scope as the setup. You don't have to pass any kind of values. You can just use global values for everything. In fact, you don't want to use the local keyword because that results in weird things happening. Just because of the way the scoping works out. And so it'll access these variables and it'll just plunk them down in the code. Now you can put arbitrary Lua code inside of this marker, but it should be code that returns something. If it's code that doesn't return anything, you'll wind up getting like a nil there, which we don't usually want. So to go give this a try real quick, you can try out a problem without saving it. If you're doing a lot of complicated stuff, it's a good idea to save from time to time. So here we have the random seed, and I'm just going to go ahead and try this out with random seed 0. And so you can see that what gets generated down here is just based on what's typed in for the template. Now, underneath what's happening is any of the code in any of the text you've put in here, so if I wanted to make this more complex, what is the sum of R1, and R2? If I did that instead, it'll do that instead, right? It's just doing whatever I type in here. It actually, underneath, it's getting converted into print statements in Lua. Because it's all really being a little Lua program. Now, if I change this random seed here, right, so we go from 0 to 1 and we try it out, I'll get two different numbers that we are summing up. I should add, by the way, when we're doing random in Lua, math random 10 does a number from 1 to 10. That's one of the things that for people who've done a lot of programming in C or Java or Python, for instance, everything is 0 indexed in those languages. In Lua, everything tends to be 1 indexed. And so that includes the random number. Instead of when you do 10, it doesn't, like in Python, if you do random 10, it gives you a number from 0 to 9. Or maybe random int 10. I don't know. It's been a little while since I've done the Python. But this one will actually give you a number from 1 to 10. It's just you can look that up in the standard Lua docs. So I don't know why I did the +1 here, because it's then R1 and R2 are actually numbers from 2 to 11. I think maybe I'd been writing too much Python. I might get rid of that +1. But yeah, so each time you change the random seed, you're going to get a slightly different version of the problem. When you're trying out the question, it's a very good idea to try it out with some different random seeds to make sure that you haven't made mistakes. So for instance, one of the students at Park University who was writing dynamic problems for that course, who's being a TA for that course, wrote something that was doing number-based conversion, and it turned out with certain random seeds, it generated, he generated a series of digits, and each digit was supposed to be 0 to 9, but in fact, it was turning out being 0 to 10. And so occasionally his code generated the digit 10, which then it turned out didn't work with the rest of his code. So you have to be, a little careful with it, because it is totally possible to write problems that work properly with random seed 0, but do not work properly with other ones. Okay, so our second set of syntax inside of this is the bracket curly brace. I chose these, by the way. The reason we go with bracket, square bracket, vertical line, and square bracket curly brace is because I expected this probably to be used in computer science classes, and I couldn't find any languages that use that as like common notation for either of these. Obviously, you can wind up with this if you're doing, I don't know, a set inside a list in Python in your example code or something. Which, if you're doing that, just, in your Python, put a space between them, because our processor will otherwise treat that as the beginning of Lua code. And you need to have at least one code block in every problem. You can put as many as you want. We'll do an example next where we complicate this by adding a little more Lua code, and yeah, we'll basically next we'll do sort of a different problem. But the thing that is required is every time you want an answer blank, because if we go down and we look at this example problem here, we have both the text and then we have an answer blank here, right, for the student to put their answer into. I might go 14. Yay. I'll tell you why it's 12.5 in a moment. That's my fault. So we have to call this make answer function. That's the function that actually creates the answer blank that they're going to fill in. It would be sort of technically possible to like write it in HTML or something like that, but then it wouldn't be hooked into our system. So to make these answer blanks, you do have to do a make answer here. So make answer has 6 fields. The first one is a name for the answer blank. And this will be when the students see that they've gotten, if there's more than one answer blank and they've gotten some parts right and some parts wrong, they will see this name in order to know which parts they got right or wrrong. The second one is a data type for this. We have a fairly limited number of data types. We've got number, string. Actually, does our help list them? It should. We have a little help up at the top of template dynamic problems, which summarizes some of this. I'll get you guys in. Let me document somewhere what the types of the answer blanks available are. It's not very many. It's basically numbers and strings. And then we have a code one, because we do have a way to run code. I don't know if you're interested in using that or not. It's a little bit not entirely, it's a little bit fragile, but it's totally doable. It's not fragile on the student side, but it's a little complicated for the instructor to set up. So if you guys are interested in doing things where we have the students type code and then we check it, let me know, and I can provide you with some documentation for that. So anyway, so we've got a name, we've got a type, we have a, this one's actually a size field that we wound up not really using. I put this in there initially because my expectation was we would have sort of different width answer blanks depending on the particular problem as a way to, hint to the students about how much space they needed. But when we switched over to the CSS we're using for this particular one, you can see every answer blank goes the full width of the, every answer blank goes the full width of the screen, essentially. So the size field wound up not actually being used. So it doesn't actually do anything. So for the size field, you could actually put like literally whatever you want. I don't think we do anything with it. And then the next part is this is where you put the answer checker. So, and we have a number of different ones that are available. So this is the exact equality checker. So this is actually a function that is then in turn going to return a function. We can talk about those more if you want. I'll go through the list of equality checkers or answer checkers at some point too. You can write your own answer checker. It can be written as a Lua function. We've done some specialized ones for some different courses. So we had someone teaching a discrete math course who really wanted one to check where the results were sets, and they really wanted to make sure that they were getting the correct set and that they were using the notation right. So we wrote one for that. Yeah. Okay, and then the next field is how many points the problem is worth. And this is why things went slightly wrong in that up here, I had said that in part 1, there was a total of 8 points, and then I awarded 10 points. And this is why it wound up adjusting it to a scale and giving more points than that. In the example, I think it's actually treated as a 10-point problem total when you try it out. So it was saying this part was worth 8 points, and then I gave 10 points, and then it adjusted to the fact that there were supposed to be 10 points total in the problem. Actually, I should say that's set somewhere up here. Yeah, okay. If points hasn't been set, it treats it as a 10-point problem when you're trying it out. And so that's why we wound up with 12.5 points, because I had told it there were 10 points total in this part, or 8 points total in this part, and then I awarded 10 points. So there is no check for that. You have to manually make sure that if you have made different answer blanks that your total does match up here. So I could I could add multiple answer blanks down here. If I said there's 5 points in this, there are 10 points in this part, I could do two 5-point answer blanks. I could do a 2-point answer blank and an 8-point answer blank, right? Whatever. And then our last thing, and this wasn't actually in the documentation until last night. Charles thoughtfully moved over the card in Trello saying, "Hey, you really need to add this to the documentation." And it's like, oh yeah, we do. We added this by request. So this is an example correct answer. Answer checkers don't necessarily have the answer checkers. Most of them are based off of having a correct answer to compare things to, but there's nothing in dynamic problems that requires that. You could have a problem that says, I don't know, give me an odd number, and then your answer checker could just check to see if it's an odd number. So this is not guaranteed to be something that's guaranteed to be the solution, right? Because you don't necessarily have one correct answer. But it should be a correct answer that can be displayed to the students. And this is for when they're working on, not necessarily for, say, graded tests, but for practice problems. If they don't get it right, it's nice for them to see an example answer. So we added this at a certain point. For this case, it's fairly straightforward because you can see, obviously, we're just putting the same answer we put into the exact equality checker. But there's some where some of the checkers take things like lists or arrays, and this needs to be rendered down to just a number or a string so it can be printed out directly. So there is so to support that, you do sometimes need a little bit of extra Lua code. Okay, so yeah, so what'll happen is when this gets called, it renders the HTML that's actually going to make this answer blank down here. I should say also, when they're entering their answer, the name of the answer blank shows up underneath. So if we wanted to do just a little expansion of this, if we wanted to also say, ask them the difference, and make this a second answer blank, right, we can do that. I'll be lazy and copy and paste. So we'll do R1 minus R2. And this, of course, may give us a negative number, which is fine. Okay, and so then this one needs a different one. So like we can give them, it's not a bad idea to give them meaningful names. And then we have to adjust the points in some form. So if we need 10 points total, well, or I could just make this 20. Let's just make that 20. Yeah. Oh, I see what's happening there. When I'm scrolling with my mouse, it's changing that number. Oof. I don't love that. And we perhaps should have put a little extra space in there. But so I can try this out, 14. And I don't know, let's go get that one wrong. 8. And you can see then when it does, it'll tell you how many points you got. This again, because I didn't fill in a number of points for the problem in the challenge. It's treating it as a 10-point question and then scaling things appropriately. So I got 5 points for the first one, and I got 0 points for the second one. And we do have a thing where they can retry, and you can set how many retries are available. But that's true for everything. Is the retry not working in the try it out? Oh, no, it is. Okay, right. We just, they can go change it here. Right. There we go. And that one, we're down to 4.5 points because when we set up the retry, they lose 10% each time they retry. That's just, yeah, that's independent of whether or not it's a dynamic problem. Okay, so does all of this basically make sense to people? Do people have any questions about this so far?
So far, good.
Yeah, it makes sense, Professor.
Okay.
Yeah.
So let's do, I was going to do, as an example then, instead of just something quite this simple, I was going to go ahead and do a programming example where we might, this is just one from, say, an intro programming course where we might ask the students what the output is of a program at a certain point. And so to do this one, I was going to go ahead and kind of start out by actually writing a static version of the problem, and then we'll look at how we make that into a dynamic version of the problem, right? So, oh, we're still in bold. Let me unbold us. Okay, so let's do a, what does the following program print out? Right, and I'm going to switch us over into computer code. There we go. Just to use a little bit of the stuff. Okay. So we'll start off, oh, let me do shift enter. Why did shift enter? Okay, there we go. I know, rich text editors are always a little fiddly. I find this one actually a little better than the one I have to use in Canvas, but it's still a little fiddly. Okay. Yeah. We'll do this. We'll do it in Java. Okay, so just elementary programming. Like, what does this print out? And then we're going to go ahead and complicate this some by let's see. Let's pull that. Turn computer code off. There. I'll just put a little note for myself. Answer blank here. Okay, so this one, of course, this is a fully static problem. And we might look and say, well, where can we make this dynamic? And say, well, there's a number of different things that we might want to change. Obvious things are we could change how we're initializing X and Y, right? So we could say, let's go add, right, init X and init Y, right? And then what I'm going to need to do then, of course, is I'm going to go up here and set these to random numbers of some form. Oops. The code entry, by the way, is good at catching syntax errors. So if you ever see that, like I was up here initially and I had that X there, definitely pay attention to that because it's quite good. It catches most of the syntax errors. Oh, I should say, by the way, if we do have syntax errors or runtime errors, you will get appropriate error messages. So if I go down and do a tryout question right now, it will show. Oh, actually, that's a slightly weird place for that error to show up. I will have to try and recreate that and double check. Sorry about that. That was working more accurately when I last tried it out. I think we've hit a weird edge case where for some reason it's thinking the error is in a different place than it is. Most of the time you'll get a correct error message where it will show you where in your code you made the error. But I seem to have stumbled on an edge case there, so sorry about that. If you see one of those, I'll try reproducing this afterwards. But if you do see one of those, let me know and we'll try and do it. We just changed how the sandboxing works, and that had a little impact on the error reporting. When we tested it, when we tested it, everything we tried seemed to be correct, but we clearly have a weird little edge case there. Okay, so we can set up X and Y as just random numbers. So I'll just, in this case, do random numbers. Let's do, I don't know, we'll do actually 0 to 10, right? So we'll do that. Or actually, let me do the clearer syntax for that is to do this. So from 0 to 10. Now, the next thing we might do here is we're doing like X plus Y. Maybe we sometimes want to do X minus Y or X times Y. So we might have, say, 3 different operators that we want to choose from. So let's go ahead and set up, we'll just do math.random3. And then we'll do and what I'm going to do here is just do a Lua table. Commas are right, aren't they? Well, it's been a little while since I've done this. Yeah, okay. No. Isaiah, what am I doing
Hey.
wrong here?
So
Sorry, this is the problem with me switching languages a bunch.
yeah, the array will initialize as just an array if you don't specify any indices. So it'll
Okay.
start at 1, 2, 3 automatically.
Oh, that's
You can
true.
just put all your strings inside.
Yeah, what am I doing wrong though?
You should have probably put the numbers inside of brackets.
Oh yeah, that's
Or
right.
done it.
Yeah, you're right. Yeah, it doesn't take it can't use Lua does not allow when you use numbers as keys for the array, you have to put them in brackets. Which I had forgotten about because a little rusty. So anyway, I was going to do this and then just does that not work? Why am I getting an error? No, let's do it. Okay. Okay, well that works. So we'll just set this up so that we choose a random number between 1 and 3, and then our particular op will be either plus, minus, or times. And then we need to so that's so now we have op down here, and I can substitute in like that. But the other thing I'm going to have to do then is I'm going to have to calculate this value of x based on this operation. So I'm going to need, well, actually, in this case, I don't really have to because I'm kind of we're not using x, but I'm going to, assuming we're going to use x a little bit later. Let's go ahead and do that. Oops. Sorry, I didn't change my focus. Okay, so x equals so let's see. What's the easiest way to do it? We'll just do if which op equals 1.
I need it then.
Actually, why don't we just do this? Oh yeah, then thank you. That one I would have gotten given just a moment, but I appreciate the help there. So let's do x equals init x. So if it's 1, then it's plus equals. So we'll just do a little simple code. Does it not, wait, it doesn't do minus. That's, sorry. Oh. I could do the equivalent of a switch statement here, but I'm just what am I missing? Oh, I'm missing a second end. Right. In fact, to make that clear, I'm going to tab that. Okay. Okay, so then that'll give me an up-to-date value of x. Right, so we're just writing a little Lua code to emulate the same thing that's going to happen in our Java code that we're showing to the student. And then down here, of course, I need a make answer. And so we'll call this one printed. It's a number. I'm just putting in 5 for the size because I always wind up putting in 5 for the size. And then for our answer checker in this case, we need exact equality. And we want the value of y, which is, I'm actually, obviously it's just init y times 10, but I'm going to go ahead and just for simplicity, I'm going to make a value up here called answer rather than putting that in the code. And this is worth 10 points for the 10, and the last thing here is answer again. Okay, and so then we can go try out this problem, make sure it works. So generate some random numbers. Let's see, x should be 20. Okay, well, y is going to be 30, right? Did I do some, what did I do wrong here? Oh, because this is still listed as a 20-point question. Ah. No, take the focus away from there. Okay. Sorry, so that's why, I said it was a 20-point question, then I only awarded 10 points. So obviously, that's gonna think I'm incomplete. So you do definitely need to make sure the number of points awarded by all of your answered blanks matches up with the total points. Okay, and let's say now, sometimes I want the answer to be, sometimes I want to ask them about X, and sometimes I want to ask them about Y. And so there's about 3 different ways I can do this. So I wanted to show that there is sort of more than one way we can do this. So let's do so we're going to do a coin flip, and ask X will be a Boolean variable. So so one way we could do this is the same way we did it for the operation. Right. Right, we could do something like that. And then here we could do, right, versus answer equals init y times 10, right? So we could do that. And then we could just put ask var down here, right? And that's probably what I would do if I were actually writing this. But for demonstration purposes, I wanted to show the other way we could do this. So I'm going to get rid of this ask var string here, and we'll still calculate the answer this way. So we know what our answer is. Well, actually, let's not. Let's even. Okay, so we've set up an ask X. So what I wanted to show is what we can do here is we can, let's go change that back. We can actually, at this point, we could go ahead and put in some Lua code with an if. And you can actually put in like if statements and for loops and all of that stuff directly in here. And the stuff that goes in between. Actually, let me do this. We probably don't want extra new lines in there. Okay, so we can totally go do this, right? if ask x, then system.out printout x, else, right? So you can wrap rich text parts inside of ifs or inside of fors or whiles or whatever, and it will repeat this code or show or not show this code appropriately. And then likewise down here, we could do if ask x, and we could do two different make answers. Well, actually, let me copy that one because it's not a lot of fun, I think, watching me type. Now you can see you don't get the nice like syntax highlighting and correctness and everything. So let's see. So instead of answer here, if we're asking X, we do X. And if we're doing that one, it's init Y times 10. And we need to do the correct answer here as well. And I need end statement since I have an if. So we could do this instead, right? Where essentially we're doing, we're using the ifs to bracket around code, like code that's actually the formatted code in the template. And this will work perfectly fine.
Where did you define ask X?
I defined ask X up here. So this was our Boolean.
Okay.
And of course, any of this you could do in the template. It's just nicer to do it up ahead of time because then you get the formatting, you know, it flags your syntax errors and all of that. Whereas obviously the rich text editor doesn't know anything about the Lua, is not expecting the Lua to be there. It doesn't format it nicely or flag your syntax errors or anything. So if I didn't make any errors in doing that, when we go try this out. Oh, I'm missing a then. So. Okay, so you can see that one, I did get the syntax error where we would expect it. So most of the time it will give you syntax errors. And oh, I forgot to put my math dot in front of my random. So although I showed you where I defined ask X, I did not define ask X appropriately because I forgot the math dot. So yeah, you can see the I guess the good side of this, aside from seeing that I'm imperfect, is that it does tend to show you your errors where they actually happen. I don't know why we hit that one weird edge case where it was saying that it happened in a place where it didn't. Like I said, I'll check on that. But. Why is evaluate? Oh, because it, sorry. Why is it doing that? Did I hit, oh, I hit submit problem part instead of try out, so we still have the same error. Okay, there we go. Sorry, I tried to resubmit my correct answer instead of doing it. So this time, you can see that's working properly now that I've fixed my bugs. And of course, we would definitely want to try this with some different things. So like this time it asks us for X. Why did I put that in quotes? I don't know why I put that in quotes. Neither of those should be in quotes. That's just, that's a bad problem to give to the students. But anyway, so you can see it'll give us, it'll randomize the values, and we can also switch between X and Y. So there's a lot of flexibility here. And the other thing you can do, if we wanted to do this, is if this, just to give as an example, so we've got our code here. I'm going to leave that one as it is. The other thing we can do is when we go into Lua code here, you can also use print statements. And print statements will get output to the template as well. So you can see what this does here is this part here, we drop into Lua code. I need my end.
Do you want the quotes there?
Yes, because in that case, I'm printing a string in Lua.
Okay.
It's probably because I practiced by doing that the other day that, yeah. So this is actual Lua code, and you can see, so when we do this print here, it'll add that to the problem, whatever is inside of a print. So there might be situations where that's an easier way to write something. This one obviously is not necessarily easier. And this will just work the same way as it did previously, just with a slightly different approach there. So that's pretty much, those are your options there. You know, we can use, if you want sort of ifs, you know, if you want values, you just kind of write arbitrary Lua code up top. If you want, say, to print out different things in different circumstances, we can either do code blocks with prints inside them, we can do the if-elses involved, or you can set up strings up above. The other thing I did want to say, too, is that, by and large, the rich text formatting, of course, does not know that these symbols have any special meaning or anything like that. So there are certain things you can, so it doesn't, you do want to be careful to not overlap the rich text formatting with your code. It's actually perfectly happy. You can see, like, this is code that is inside of formatting, right? This is inside of the computer formatting, the computer code formatting block, and that plays perfectly nicely. The only thing you don't want to do is do something like, you know, be like, oh, let's make this bold, right? Because of course, what that actually does, if we go try that out, I really like printing X, so I made it bold. When I go try out the problem, I'm going to get an error because, of course, the rich text has inserted HTML tags into the middle of my Lua code. You can, so that's the only thing you don't want to do formatting wise. You know, you don't want formats that go across your code or that happen in the middle of your code. But other than that, it works perfectly fine. You know, like if we format this entire thing as bold, then it'll just make whatever gets printed out here bold, right? Because the strong will go outside of this, and this will actually run fine. And it just, well, it doesn't actually make that X visibly bold because the computer code format thing overrides the bold. But it would if it weren't in the middle of the computer code thing. But yeah, you just have to sort of think of the formatting as being extra HTML tags. So has all of this made sense to everyone? Does anybody have any questions about this?
So far, so good.
Yeah, good, Professor.
Okay, so I wanted to talk just to show you. Okay, so the only other thing I wanted to show then is I did want to show libraries. And so the way so let's go actually pull up the so I sent you guys this URL for documentation for answer checkers. We have two modules here. The OneUp ones these are all built in. You don't have to do anything to add these. So you can see I have the exact equality one here that we were using. The other two that we have that are available right off are approximate equality, which just, it takes an answer and then a ratio that it has to be within. And this is very helpful if you're ever dealing with like floating point numbers, because floating point values are not, you know, because they're binary, they're not exact representations of the equivalent decimal number. And so you can wind up with two answers that look the same but don't actually come as equal. or the calculator doesn't give you exactly the same number that the computer does, and that sort of thing. So I highly recommend using this one with at least, a small fudge fraction if you're doing any kind of floating point numbers. And then we have a simple string equality. It's a case insensitive and it ignores spaces. Those are the three that are built in, and you can just use those at any point. We also have, we had written some additional checkers that we had mostly been passing around to people with copy and paste. Because if you've written your own answer checker, you can put it in the setup part. Most of the time, I don't think you'll need to write your own answer checker. But if you do want to write one, if you have something that's not a case that's not covered, I will be glad to help you with that. Writing an answer checker is a little more complicated because it's a function which returns another function that then supposed to return a table with particular qualities. But we have a module called answer checkers, and I've uploaded this to the server. This right now just contains the other answer checkers that we've written. So there's an exact equality, but with a partial credit range, so that, you can say, in this case, in my example here, actually, let me go ahead. If you call it with 120, and then it's correct if they're within 20, and then they get half credit if they're within 20, is essentially what this set of arguments is saying. Then, if they say 120, they get 10 points, but if they say 110, they get 5 points. So I don't know. I wrote that initially. We haven't had a lot of demand for it. It's mostly just sat there. We have a word list equality. We use this in our data structures class for stacks and queues. We have some problems that do random stack and queue operations and then say, what does the stack look like? And so the word list equality is expecting then a list of words. In Lua, what we have to create is a Lua table, basically being a list or an array that has the list of words we want. But then the students, when they enter it, can put any kind of spacing or punctuation between the words that they want, and it will still count it. That one is order sensitive. And then we also have a set equality. And as I said, this came from a discrete math class that was being taught at one of the other universities, where I don't know why my examples aren't there. Anyway, I thought I had more examples about what was correct and what was incorrect. But anyway, and so this one does a similar kind of a thing, except it's pickier. So one, it's of course order insensitive because it's a set, and then it's pickier because it wants you to use commas and it wants you to use curly braces. If you use, I don't know, semicolons or parentheses, it's not happy. Or if you just leave those off, it doesn't count that as correct. Although it does actually, it will give you a more specific error message than based on what you've done wrong.
Does it ignore spaces around the commas?
It does. So it ignores any kind of white spaces or tabs, or even if somebody smuggles in a new line, which I think they'd have to copy and paste in, it'll ignore any kind of white space. So, I tend to be a proponent of making things as flexible as possible, but the instructor was like, no, it must have proper set notation. And I'm like, I can see why you would want that in some cases.
Yeah.
But so anyway, so those are the ones that we already have. To use a library in OneUp in your code, you just go up here to this add dependency, and we have libraries that exist. The test one doesn't really do anything. The IP one is from a networking class from Park University. We'd have to check with them to see what's actually in that. And then the additional checkers one I just added. In Lua, you usually use, require or load? Anyway, there's something you usually have to do to load a library. You don't have to do that. Our stuff does it automatically. Once you've added it to the dependent libraries, you can go ahead and use it. And so then at this point, this is where, you know, if I wanted to do, you know, instead of the exact equality, I wanted to do set equality, right? This is where I would go change that. I would, of course, need to, obviously, in this case, X is a number, and that's not what the set equality checker is expecting. But, and you can see, of course, there's multiple arguments for the checkers, and these just go right here, and it doesn't really change the rest of the make answer structure. But of course, you can use these, anything that's, if you find you're using a lot of the same functions, you can set up a library, you can upload it, and then just use it through here. And you can use it in your setup code or wherever as well. So, yeah, so that's, I think, most of what I had planned to talk about. The only other thing was I did add the, I uploaded the dynamic problems. Let's see, that should be on main. Yeah. We have a cryptography library that's in progress. Don't worry about that. But if you want to look at some of our example problems, these are ones we've kind of had these kicking around, and I think we sent some of them to you. But this is our full, like, this is everything we have. Because, yeah, I mean, nobody was trying to, like, keep anything secret. It was just a matter of getting things around. So I went ahead and uploaded this to GitHub. I sent you guys a link in the email. And so, because you guys are doing discrete structures, which I believe is like discrete math, is that correct?
Right.
So we have a bunch of discrete math problems already written related to, say, logic, number conversion, probability set theory, summation. And these were from the other discrete math ones. So one, feel totally free to use these. And then two, they might give you some good basis for things.
Exactly.
So, and both they generally have a setup and a template code. The template code, some of it will be .txts, some of it will be like ODTs or RTFs, because they might have wanted to preserve the formatting. I don't know if those. So anyway, so like this one you can see is sort of a more complicated one where he's setting up a truth table. I don't, yeah. And so this one, like, it has the word list equality built into it because we hadn't added it to a library at the time. So, but yeah, if you put in the setup code, and I think I'd have to open that. I'm going to skip opening that one. Let's see if we've got one that, no, that's an ODT as well. Okay, so like here's a binary number conversion one. So this one gets a random number between 100 and 999, so a 3-digit random number. We've written, there's a little 2 binary function. And then we take the bits and we make them into a string by doing string concatenation. That one does, yeah. And then it actually converts it to an integer because they wanted to use the exact number. I probably would have done the string for that one, but that's okay. Yeah, so that one's fairly straightforward. We have some, I will say, if you go look in the data structures one, we have some more complicated ones. You are allowed to output JavaScript if you want to. There's no sort of built-in support for it. but if you, when your code, your template code is say printing things out, it can print out anything. So it's totally allowed to do JavaScript. So there are times where if you want to make a particular visualization or something, you can do JavaScript for that. Oh, and I should say, by the way, if anybody wants to do LaTeX formatted formulas, we do have support for that. But if you're going to do something like, I don't know, so let's do, I don't know how much people have done LaTeX here. I do a lot of LaTeX. So let's say I wanted to do something like this, right? Oh, whatever my fraction 1 over init x. If I do this the default way, and then try out the question, I will get 1 over init x without the value substitution. But that's just because when you go look at the HTML source for this, which you can do, you can see it's actually pulled out the bracket curly brace and HTML encoded them. And if you actually just go in and put those back, then our code will find it and will do the substitution again. So it's because it's done through this sort of third-party website and it's HTML encoded, but you can actually do that. So now if I go try out the problem, it will substitute appropriately. So if you do want to use LaTeX, which you might, it's a mathy kind of a thing, that's what you have to do in order to do it. So. Okay, so
if you just use the math functions that are in your editor, you don't have to do that, right?
Yeah, if you're not trying to put a variable in, you don't have to do anything special. But if you want to add a dynamically generated, a random number you've generated or something else you've generated in your Lua code into the LaTeX, that's where you have to go do that.
Your editor is making LaTeX. Okay.
Yeah. Yeah, the editor is actually, it's handing off to a third-party website that makes LaTeX. So, but yeah, if you're doing the insert equation in the editor.
Okay.
So, and the rest of the stuff it works because it's all adding HTML tags, and that doesn't really interfere with our, square brace vertical line or square brace curly brace. So.